process control using Amatrol T5552. Some of this stuff we may skip over. Some of it is just tags that you learned in the earlier stages of doing the computer side of things. And the tags are on every device on the trainer, and they are labeled as such as they were in the earlier computer lesson portion of it. So first off, we're going to start with safety. It's 110 volts. It is plugged in. There's a power switch with a lockout device for it. It is GFI protected. It has a GFI trip on it. The alarm horn is on this side. And this is a basic, in my opinion, this is a basic water plant. You have water in an aquifer. You're pulling water out of it. You're either treating it or putting it in a storage tank. You're running the storage tank based off of either a level with floats or with a transducer. You have flow meters. You will start it, stop it, add chemicals if needed, treat the water, whatever is needed, and then you send it back out. All right, in the first lesson here, we are going to manually control the liquid level in a tank using an open and closed loop method. So what it says is set the regulator to 0 psi, because we don't need any pressure in this lab. And then it says connect the circuit as shown. So we're going to go ahead and connect this circuit from selector switch 1. We're going to go to the DC power supply. From the other side of selector switch 1, we will be going to the pump. From the negative of the pump, we will be going back to the negative of the power supply. So basically what you have here is 24 volts going to the selector switch, which is normally open. When you flip the switch, it will close it. Can make the 24 volts go to the circulator pump, and then the circulator pump needs a negative to complete the circuit. It is now wired as shown. And then it says make sure the hand valves HV100B, which is HV100B, and HV100A, in the process piping are both fully open. They're in line with the pipe, so they are open. Make sure the flow control handle valve 100D is fully open. 100D is over here. 100D is in line with the pipe. It is open. Make sure the two process tank manual drain valves HV300 and HV100C 300 and HV100C are closed. So as you can see, these are now sideways rather than in line with the pipe, so they are closed. Make sure the manual flow valve FV100 is completely closed, fully clockwise. So that's the clockwise position. Make sure the T5552 electrical process cord is connected to the outlet, which it is. Turn the main breaker on. The control power indicator light above the circuit breaker should be lit, indicating the control power is present. If the indicator light is not lit, check the power cord to make sure that it's plugged in. We are lit, and we do have some devices lighting up so we know we're lit. Turn selector switch 1 in a clockwise on position. You will hear a pump start. I do hear the pump. Even though the pump is now running, there should be no flow in the water into the process tank because the manual flow control valve, FV100, is closed. Open the manual flow control valve by turning it counterclockwise until the flow rate indicates on the rotary meter, as shown in figure 310, about 1.3 gallons. So as we slowly open this meter is going to go up and we're looking for about 1.3 gallons, so where that red is. And it is rising. And that should be about 1.3 gallons. When the level in the process tank reaches about 5 inches, open the process valve on the right side, manual drain valve, HV100C. And as you can see, since we've opened that and we're putting 1.3 gallons through here, this process tank is filling up. It's taking it out of the storage tank and filling the process tank up. So it wants us to let it get up to about 5 inches. And then once it hits 5 inches, it wants us to open the manual drain valve, HV100, about halfway and allow the water in the process tank to drain into the reservoir, causing the level of the process tank to begin to drop because there's now a demand on the system. And it says increase the flow into the process tank by adjusting the manual flow control valve, FV100, until the level returns and stabilizes about 5 inches. So what we're doing here is, as this is pumping in, there's no demand on the system because both of these valves are closed. So this level in the tank, in the storage tank, is just increasing, and the process tank is increasing. If I was to open this to put some kind of demand on the system, you're going to start seeing that this is either going to level out or start dropping, which it drains more than 1.3 gallons, so our process tank is actually dropping. So now I'm going to slowly start backing it off, and that is kind of a maintain there. We're maintaining right about 2 inches. So if it's maintaining the system at 1.3 gallons and the pump kicks on and starts giving us more, our tank is going to recover because we're putting more water into the process tank than we are using. If we stay at our 1.3 and demand on the system stops, we'll start increasing in our process tank again. If demand increases, then we will start losing in our process tank. The next set does exactly as we were just talking about, where we were increasing and dropping our level in our process tank depending on demand. And it also states to use the sight glass to know how much level is in the tank, which we were using the sight glass as we were going through. It's from 0 inches to 10 inches of liquid level. This next set is the instrument tags. The instrument tags were all gone over earlier when you were doing your computer-based side. The only difference is here, you can physically see the instrument tags while you're doing it, where it was just a picture previously. Now we're going to go into a loop controller. This is a Honeywell loop controller. There's many different kinds out there, many different brands. For this instance, we're going to be using the Honeywell. We'll go ahead and remove these from our last lab. And we're going to move into this. So it says perform the following sub-steps to power up the controller and observe the display on the controller. Make sure the main power cord is plugged in. It is. We're going to go ahead and turn the breaker on. we're going to observe the controller. It should say test and then test done, which I believe I missed that because it's pretty quick. I'm going to jump to this side. Test done. So that portion is good. So if there was anything that this controller seen that was wrong, it would have went into a fail-safe condition. And it said test done, so it did not go into a fail-safe, so we were okay. So now it wants us to shut the main breaker off, and it says turn the main circuit breaker on again. Wait for the test done to display. While the test done appears, press and hold the setup key and the function loop half key simultaneously. Release both keys. This causes the controller to run a display test. During the display test, all elements of the display will light up. So let's go ahead and try that. So we're going to kill the breaker. We're going to be pushing, try to stand off to this side. We're going to be pushing the setup key, which is here. And we're going to be pushing the function loop key, which is above it, once we see the test done. And there you can see everything is lit up. So it's tested the display. Now it wants us to test all the keys. It says function, lower display, auto manual, set point select, setup, increment. So everything worked. So we're good to go there. Now it says turn off the main circuit breaker. Then it's just going through the menus of what parameters you can adjust. And we will be going in to adjust a few of these settings here shortly. Alright, so next one says change the Honeywell or UDC 3500 loop controller parameters. So we're going to be turning the power on. We're going to wait for test done. Once the test is done, we're going to press the setup key. We're going to perform the following. We're going to press the setup key repeatedly to scroll through the parameter group until you come to input 1 parameter. So we're going to push the setup key. As we're pushing it, the lower section is changing. So now we're at input 1. Once we're there, we're going to press the function loop half key 1 time. And the controller display, the first parameter, input 1 parameter, IN1 type. And we're going to press the up or down keys to scroll. And once the setting is returned, you get 1.5 volts. So we're going to change this to 1.5 volts. Then we're going to press the function loop key. The next setup should be X-mitter. Should be set to linear, and it is. Press the up and down keys and just come back around to linear. So it just wants us to scroll around. And then we're going to set it right back to linear. But then we're going to press the setup key. X meter is linear. Use up down keys to change the setting to square root. Square root. Press the function loop key to in1 high. In1 high, we're going to set to 25, which right now it's at 27.7. So we're just going to go down to 25.0. Alright, we're now at 25.0. We'll press the function loop key for low. Low we want to be at 8. These things are a little finicky. You got to be careful because they'll start really running. Like that one did. Get this back there just a second. 8.0. And now we're going to go to the control setup. In the control group, we're going to be looking for PV source, which is the first one that comes up. Use the navigate until we see the set point high limit. Set point high limit. We're going to change that to 24. Basically what we're doing right now is just setting this controller up for the parameters that they're asking for. So we're set at 24. Now our next one should be low limit. Low limit it wants set at 10. If I would have moved the decimal place, this would have been a little bit easier to achieve those numbers faster. Right now it has 2 decimal places. If we take the decimal place out, it would just be whole numbers. So continue to press the lower display key until we see set SP, lower display key. We see set point. So we see a set point. Use the up and down arrow keys to a value of 15. We're now set point at 15. Turn off the main circuit breaker and shut down the trainer. So it made us change those parameters for no other purpose other than we're now going to reset the controller. And by resetting the controller, it's going to take everything in it back to factory. So we're going to turn the main circuit breaker on. While the test done light is on, we're going to press the function loop and we're going to press the up arrow at the same time. And that's going to bring us to our factory restore screen. So we're going to see update. That didn't work. Turn it on, press and hold. Update comes up, we're going to press the function loop key. It's going to say restore disabled. When it says restore disabled, we are actually going to hit the up arrow until it says configure. Once it says configure, which it does, we're then going to press the function loop key, and it's doing a restore. So now this unit is now factory restored. And later on, when we're in there doing stuff, we are going to get to a point where we have to do a factory restore because it's not going to work. So I'm going to fold that corner back so hopefully it'll be a little bit easier to find. So now we're going to turn off the main breaker, and we're going to connect and operate a loop controller in the manual mode. So we're going to wire this up as it's shown in the picture. We're going to set the regulator to 20 psi. So we have the regulator now set at 20 psi. Fully closed clockwise, the left side process tank manual drain, HV 300, which is closed. So I'll go ahead and drain this. Open the right side of the process drain approximately halfway. So now that we're drained, we'll go ahead and make this about halfway. Fully open FV 100 in the fully counterclockwise position. So that's fully counterclockwise. Fully open HV 100B and A. They're both open. Connect the circuit as shown. So we're going to come off of the analog output, and we are going to go to the flow valve, positive to positive, and negative to negative, once I find one long enough. And then we're going to wire up the pump circuit. So we're going to come off of 24 volts. We're going to go to the selector switch. From the other side of the selector switch to the pump. From the pump's negative back to the negative of the power supply. We're going to remove the lockout device. We're going to go ahead and turn this on. So once this comes on, this controller is in the manual mode, which is what we want. We want output on the bottom, which its output is 0 right now. We're going to turn the selector switch on for the pump. When the level increases to 2-inch mark in the tank sight scale, adjust the output from the controller using the up and down arrow keys to stabilize it at 2 inches. Increase the output of the controller, causing the diaphragm of the control valve to close. Decreasing the controller, the output will cause the diaphragm to open. If the level rises above the 2-inch mark, increase the output enough to make the level drop to the desired point. If the level falls below, decrease the output to bring the water in. So we're above it now, so we're going to go ahead and start increasing this. As we increase this, the pump is going to start slowing down. We have an output right now of 27.9, and we're still gaining. So I'm going to go ahead and drop it. I'm going to go ahead and take this to, let's say, 40%. So I'm going to go ahead and close this about 80%. So at 78%, we are just holding steady. So I'm going to go a little bit more. At 90%, 90%, we're just starting to drop back down. So I'm going to go ahead and drop down a little faster, just so you can see the inlet pipe from the process tank there. I'm going to leave this open just to kind of give you an idea. I don't know, if maybe hard to see on the screen, but right now there's no water coming in. As I decrease this air valve is going to open, allowing more water to come through, and you're going to start seeing that the water starts increasing. The amount of water coming out of the pipe starts increasing, and the level is going to start going up. So that is just a way of using an analog output from this device to a flow control to maintain a level. But currently we're using it in a manual mode. So as we need water, we have to increase or decrease to open or close the valve to put more water in the tank. Soon we'll be doing it automatically. So basically what you're doing is we are increasing and decreasing the analog signal. And in this instance, the analog signal is a 4 to 20 milliamp. And some of this I'm just flipping through because I'm describing it as we go through. Connect and operate a diaphragm actuator proportional valve. So it looks like we are going to, and this is actually the exact same thing as we just went through. If for some reason your scaling wasn't correct, where your 4 milliamps was either fully open or fully closed, and your 20 milliamps wasn't fully open or fully closed, the opposite of the 4. You actually have some adjustments on these air actuator valves. You can adjust it tighter, on the diaphragm or looser on the diaphragm to give yourself more flow. If at 4 milliamps you wanted 0 and at 20 you wanted 100 gallons a minute, you could adjust the spring on the diaphragm to open and close this valve only to a certain portion. In some instances, you might have an FBLS. It's the level that you're allowed to draw the water table down to, and a gallons per minute requirement. If you have that, you may have to adjust this valve to only allow so much to come in. So this is converting pressure into a level. When you convert pressure into a level, the formula you're going to use is 2.31. So for every 2.31 feet that you have of a liquid level column, you have 1 psi. So at 231 feet, you're going to have 100 psi. So anything you need to convert from level into pressure, you would use the formula of 2.31, and that's going to give you your pressure. That's why we use, in the water industry, we use overhead storage tanks, because if we pump it out of the ground and put it into an overhead storage tank, that's free pressure for us. We don't have to use electricity for a pump to boost that pressure up. You've got it sitting in that tank above ground, and for every 2.31 feet that your tower is, you have 1 psi. Some of this is just really redundant that we're doing here. So this is the exact same thing that I just looked through. Looks like some of these are doubled up. All right, so now we're going to control a tank level using an on-off control. So what we're going to do is we're going to be breaking this down, and we're going to wire this up. So there is, we're going to use these two floats in here as a on and off switch to control a level in this tank. So now is where it's starting to get a little bit more automated, and you don't have to have someone just turn it on, fill the tank, and turn it off, you know, as the tank gets full. All right. The air supply line should be connected. Adjust the pressure to 0. All right, we're at 0. We're going to fill the reservoir tank, which is already filled. We're going to HV 300 and 100, which are these valves over here. We want those to be fully clockwise to close position. So we're closing those. Open fully counterclockwise to flow HV 100 B and A, which they're still open. Open fully HV 100D, which is over here. It's fully open. HV 100 fully closed to clockwise. Now we're going to connect as shown. This one's going to give us a ladder diagram and a wiring schematic. I really recommend that when you're wiring stuff, if you have a picture and it says wire it like this, and you have a schematic, try to wire off the schematic, because this is what you're going to see in the real, you know, when you're out in the field truly working. You're not going to have a picture that says, hey, put this wire here, move it over to here, put this one to here and there. You're going to see a diagram, and that's how you're going to trace it. So I'm going to go ahead and wire this up as needed. So we're going to come off of 24 volt power. We're going to go to a selector switch 1. We're going to come off of the other side of selector switch 1, and we are going to go to the control relay 1. So CR1, the coil of it. We're going to come off of the other side of the coil, and we're going to go to a negative. So this is the coil of a relay, is all it is. When this switch is on, this relay is going to be energized. When this switch is off, this relay is going to be de-energized. Over here, the center is going to be a common, and the only reason I say that is because it's connected to each. The right is going to be a normally closed, the left is going to be a normally open. So these show in the de-energized state. So in the de-energized state, from here to here is going to be open, from here to here is going to be closed. In the energized state, it's going to flip-flop those. So when this relay is energized, these will close and these will open. So now we're going to come off of 24 volt power. We can backstab or just grab another one, it doesn't really matter. We're going to go to the normally open of control relay 1. We're going to come off of the other side of control relay 1. It doesn't really matter what colors we use here. Off the other side of the normally open, and we are going to go to we're going to go to actually two places. We're going to go to the LS1, which is level switch 1. And that's going to be here, level switch 1. And then we're also going to go from there to control relay 2. So we're going to come off of here and go to control relay 2. It's common. And we're also going to be going from there over to the solenoid valve 3, SV3. The opposite side of SV3 is just going to go to a negative. From the other side of the level switch 1, so LS1, the opposite side of that, will go to the control relay 2, opposite side, and it's also going to be going from LS1 to the high, level switch 2, which is they're using as a high level. Off of the other side of the high level, we're going to go to two places. We're going to go to control relay 2, the coil, and we are going to go to P1, which is pump 1, the positive side. And then we're going to take P1 back to a negative. And we're also going to take control relay 2's coil back to a negative. Kind of looks like a cluster here, but I'm going to try to insert these pictures in next to it so you can get an idea of what I did. I'm going to snap a picture of that real quick. So now what we have is, these are the two switches. This is LSH A and LSH 200B. They have floats on the end of them. As the water rises, it will lift them up and it will make or break the circuit. So now it states, it says loosen LSH 200A and adjust the screw by turning it counterclockwise to move it up or down. A shaft, so the bottom of the switch is even with the 1-inch mark. So we're going to take A, and the bottom of the switch is pretty close to the 1-inch mark now. So we're going to go ahead and leave that there. We're going to take B and have it close to the 2-inch mark, so we're going to want to lower this one a little bit. All right. So then we're going to power this up. We're going to perform the following sub-steps. Open fully counterclockwise the manual flow control valve FV100. Make sure selector switch 1 is in the off position. Turn the main circuit breaker on. So now it's on, nothing's happening. We're going to go ahead and turn on selector switch 1. When we do, the process tank should begin to fill. As this process tank is filling, when that higher float of the two gets made, this process pump should shut off, drop back down. It should open a solenoid valve, drop back down till the second switch is, both of them are down. Then the pump will turn back on till both of them are up. It's going to turn off and it's going to keep repeating itself as needed. So this would be how you would fill a ground storage tank, or you would fill a wet well in a lift station. As you, in a pump down situation, you would have it just opposite. When both of them are on, it would turn the pumps on and pump it down until both of them are off. If you wanted to fill a tank, when both of them were off, you would turn it on until both of them came on. So the process pump is currently running. Process pump just shut off because the second switch was made. When it shut off, it has opened the solenoid valve here, which is draining the tank back down. It's a smaller pipe, so it doesn't drain as fast, but the level is dropping. Once the level drops, so the second float is down, it will then close the solenoid valve, turn the pump back on, and fill the tank back up. And I'll step off to the side so you guys can watch that. we're getting really close to where now that float has dropped. Once the float dropped, it said, okay, my level is low. The process pump is fired back up. The tank, the solenoid is closed, and the tank will start to fill again. Once it hits the high level float, it's going to do the exact same thing. So we'll watch that. Once we watch that, I'll drain it down faster. We'll see it come back on, shut it off, and we'll move on to the next lesson. As we're going through these, and the process pump just shut off. So if anyone, as we're going through these, if anyone has questions about what's going on, please make note of them, and we'll, once we go over this lesson, feel free to ask whatever whatever questions you have. All right, so the next thing we're going to do is we're going to configure and operate a Honeywell UDC 3500 controller based control closed loop liquid level system. So we're going to go ahead and turn this off. We're going to be unhooking everything. Perform the following steps. Set the regulator to 20 psi. PSI. Reservoir is full. All right. So 300 and 100. 300 and 100 are fully closed. FB 100 fully counterclockwise open. And 100D is fully counterclockwise open. 100A and B both open, so we're good to go there. Connect the circuit as shown. Again, this one has two different pictures. It has the actual schematic, and it has just a picture of the device of how to wire it. So from the DC power supply, let me just make sure they're selected power supply, selector switch to the pump and back. Yeah, so they're both the same. So I'm just going to go off of the electrical schematic. So we're going to go from the positive, selector switch 1. From selector switch 1 to the pump, from the circulator pump back to the negative of the power supply. So basically this switch is just going to turn on and off the pump. We're going to come off of the power supply and go to selector switch 2. From selector switch 2, we are going to go to solenoid valve 3. Solenoid valve 3. From the negative of solenoid valve 3, we're just going to take that back to the negative of the power supply. And from the plus of the 24 volt power supply, we're going to go to the AI1 controller inputs, which is over here. Need a little bit longer for that. All right, so we're going to go from a 24 volt, come just piggyback, the AI1. From the negative of AI1, we're going to go to LT1, which is a level transmitter. Where are you at? LT1. And then we're going to take the LT1 negative back to the power supply. So now we are using, instead of using floats, this is a level transmitter. They're used in a lot of water tanks. It will take pressure and convert it to the level for you. And that's what we'll do through this controller. And it will actually increase the level and decrease the level based off of a level set point rather than floats. So then we're going to need to take the analog out of the controller and go to flow valve. So analog out and flow valve 1. Need something a little bit longer for that. And again, it doesn't really matter what colors we're using right now. There is an industry standard when you're wiring stuff in the field. So we've taken the output and went to the flow valve, and we've taken the level transmitter to the input of the controller, and then we just have one switch is hooked to a solenoid valve and the other switch is hooked to the circulator pump. Now that we've got that wired up, alright, so now we're going to turn it on. Make sure these are both in the off position. Perform the following sub-steps to set up the Honeywell controller. So we're going to, once the test is done, we're going to press the setup key till we see input 1. Input 1. Press the function loop key till we see in type. In type. And then we're going to use the up and down to go to 1 to 5 volts. 1 to 5 volts. So the reason we're going 1 to 5 volts is the level sensor outputs a 4 to 20 milliamp signal. However, the input terminals of the loop controller have a 250 ohm resistor installed across them, which changes 4 to 20 milliamps to 1.5 volts. You'll see that a lot throughout the industry if you're using 4 to 20. Now we're going to press the function loop key. We got to get back to where we were first. Input 1. Now we're going to go to X-mitter. We want to be linear, which we are. In high, we want that set at 27.7, which our decimal place is off. So we're going to have to go into our controller. And I'm going to turn the communications off so that doesn't flash in our So we got 1 decimal place now. All right, so let me get back to input 1, and our in high is going to be 27.7. Got a long ways to go here. We're at 999. So we're at 27.7. We're going to go to low. Low we want to be 0, which it currently is. And then we want to go to bias in. Bias in, we want to be negative 4.1. And what this is here is, there is, and I don't think 4.1 is correct, but we're going to find out. This is setting the offset because where this pressure transmitter is, there's a bulkhead fitting in there, and it's actually, there's a little bit of level in it previously, so you have to offset it just a little bit. It says there's approximately 4.1 inch offset between the tank and the 0 reading. So now we're going to lower display to setup menu, and we're going to go find algorithm. So once we find that, we're going to press the function loop key till we see control. Oops. was already there. Control algorithm. We're going to make that PIDA, which we're already there. And then to scroll, we're going to find control now. So once we find control, we're going to press the function loop key. And we're going to put, so we're, let's see here. Set point high, we want that to be 10. I think I just set that to 27, so. So we're now 10. We're going to function loop, we want low to be 0. We want action to be direct. We want PB. So there are a few things. PB and gain to be gain, and then min or RPM to be min. Now we're going to go to tuning. Seems like there's a lot to set up, but once you set these up, they'll stay. So if you're using this one device, you know, for the same thing over and over again, you don't have to fool with it much more. So gain we want to be 20. Just set this thing up one time, put it in action and let it go. And unless it burns up or something happens, it's going to stay there and keep right on running. Alright, and rate min is 0. Reset min is going to be 0.25. Alright. We go to comms. Already disabled the comms, so we don't have to worry about that. Lower display key to return. So now so it's all programmed, and we can see that that bias was incorrect because we're at what they're calling a 0 level right now, and we're reading a 2.8. So I'm going to go back in and get to that bias, and I'm going to change that bias to I think that was under. So I'm going to change that bias. I'm going to go down to say 2.2 and just see what happens here. So now I'm at 1.8. I got to go a little bit more. Alright, so we're at 0 now. So I changed the bias to 0.4, and that got us to a 0. That way we're a little bit closer when we're going. Alright, use the lower display key, the set point value in the lower display. So we're going to get set point is 0. We want to make the set point a value of 3. 3.0. Alright, so we have a value of 3.0. Place the controller in automatic mode. Right now it's manual. We're going to push the manual auto button for an A for auto. Turn selector switch 1 in the on position. You should notice that the water starts to flow into the tank, and the controller is sending a signal. So as the water's going into the tank, this level is increasing. So we're about 2.8, it's reading 2.6. So now that we have run that up to 3 inches, what is happening now is this controller says, hey, I'm at my set point based off of this 4 to 20 signal coming in with a level. It says, I'm at my set point. I want you to output a 4 to 20 milliamp signal to close this air valve to stop flow from coming in, because you could see how fast it was increasing. Now that we've met our set point and we've given output to that valve to close, our level is not increasing anymore. It's staying at a 3.3. So now if I was to turn on selector switch 2, which opens a solenoid valve, this level is going to start dropping. When this level starts dropping and it gets below that set point, it's going to say, hey, I need more water. This 4 to 20 is going to output to this valve saying open up some more. So now we have a solenoid valve on, which is now dumping level out, dumping water out. The level was decreasing. It went from a 3.3 to a 3.2. Now 3.1. Three point 0. 2.9. So now as this gets down below that set point, this pump, I can hear it. You can hear the air in this valve adjusting to try to maintain that 3.0 level. So earlier we did it off the floats trying to keep a level in the tank. Now we're doing it based off of a controller and a level transmitter. As it gets below 3, this valve is going to open up. Going to try to put more water in to maintain that set point that's there. And now it's coming back up. It got down to a 2.7. Now it's coming up to a 2.9. Now the controller is going to tell this valve stop. The level is going to drain a little bit based off of the solenoid valve still being on, and then it's going to open that air valve to allow more to come in. And that's just maintaining a level in a tank. All right, so we're going to go ahead and move on to the next one. The next one is configuring alarms out of this controller. Set the regulator to 20, which we're already there. Fill the tank. Valve. Connect the circuit as shown. So we're going to leave the selector switch 1. They want it still connected. Everything else we're pretty much going to disconnect. Actually, we're just going to start popping stuff out here to make it easy, quicker. So, in this diagram, it shows hooking selector switch 1 up to the recircle pump. It shows hooking up the power supply. We're going to go from the plus of the power supply to LT1. We're going to come out of LT1 and we're going to go to AI1 of the positive, and then we're going to go from the negative of AI1 to the negative of the power supply. We are going to go from the positive of a power supply to a PL2, which is just a light. And then we're going to go from the other side of the light to controller alarm output. And that is going to be right here. And then from the normally closed side of that, we're going to go back to the negative of the power supply. So it doesn't really matter where we go here. So basically what's going to happen is when we set points up in here, it's going to turn a light on when we reach a high level. Get a picture of this. So we're all hooked up, we're going to turn the power on, and we're going to set this controller up based off of the new set points. So we're going to go to setup, where first thing we're looking for is in type 1, input 1, so 1 to 5 volts, X emitter is linear, high is 27.7, low is 0. Our bias is a little different, so we're good to go there. Now we're going to go to algorithm. And we want PIDA, which is still set up. Control, we want direct. And we want gain. Want min, so we're good to go there. Now we're going to go to tuning. This is the new one where we'll have to make changes. 20, 0, 125. No, that's not the new one. All right, so now we're going to go to alarms. This is the new one. Alarms, we want type, we want to be PV. And we want this value to be a 1.0. They're tricky, sometimes they run fast. And then we want on low for our assignment. And then we want PV. And then 5. So basically what I'm doing now is setting up my low alarm and my high alarm. So anything below 1 is going to be a low alarm. Anything above a 5 is going to be a high alarm. Alright, so now that we're flipped one too many there. There we go. Hit the lower display key. So now we're out. And let me, we need to drain this down. So we're back to a 0. So now that we're drained down and we're at a 0, we are less than a 1, which was our low set point. So we have an alarm. We're currently in a low alarm state right now. As I turn selector switch 1 on, once we get to a above a 1.0, we're going to notice that our alarm light is going to go out. currently at a 1 and now at a 1.1. The alarm light has went out. Once we reach a 5 set point, which was what our high alarm was, we are going to see that that light is going to come back on, indicating a high alarm. We're at a 4.4 right now. We're at a 5. As we reach the 5, the alarm light came back on, indicating that we're now at a high level and we're in an alarm state. I'm going to turn the pump off, go ahead and drain it back down below the 5. 5.4, 5.3, 5.2, 5.1, 5, and now we're back out of a high level. So what you would do with these is you would say you had your tank and you wanted to, maintain a level between your tank of between, and we're going to use this tank, 0 and 10. So say we wanted to keep our level, we never wanted to get below a 3, and we never wanted to get above an 8. We could set our low at a 3 and our high at an 8. And control our tank level, and for some reason the pump didn't shut off or the pump didn't come on, once it gets outside of that window, it would go into an alarm state, and that would alert you that there's something going on with this equipment or the device, but you got trouble and someone needs to get there and take a look and see what's going on.
Let's see here what we got.
All right, so now we're going to be moving into some flow measurements using a flow meter and a flow transmitter. Get all this stuff going down here. All right. So where this comes into play would be if you're trying to maintain a certain amount of gallons going out to an area, or if you're trying to inject chemicals into the system, you would use this to flow pace whatever you were trying to do. All right, so let's see what we got going on here. So we're going to configure this. This is a GF Signet 9900. We're going to configure it, and we're going to be pumping some water through here at different flows and trying to get some readings off of it. So we're going to turn the main circuit breaker on. And actually we have to put some power to it first. All right, we're going to turn the circuit breaker on. Once we turn the circuit breaker on, we have power to it. We then see that the Signet paddle wheel meter does light up. All right, so turn the main circuit breaker on, select sensor, which we are set for flow, and that is what it wants us to do. We're going to set it for flow. But if we want it to go into the menu mode, we press and hold for 3 seconds. Once we go into it, we can calibrate it. Input, loop, relay, or options. It says no hold outputs. So if we want to go in the menu, push and hold for 3 seconds. That's going to take us into the menu. Perform the following sub-steps to calibrate. We're not going to calibrate it, it's already calibrated, so we're not going to go through the calibration of it. We're going to start measuring flow using the paddle wheel meter. The paddle wheel meter is plugged in, so there's a device going to it. Input is flow. All right. All right, so we're going to operate a flow control loop using a paddle wheel sensor. This is a Signet GF transmitter, and here's the paddle wheel. We're to connect the circuit as shown. Set the pressure regulator to 20 psi, which it is. Fill the reservoir, open the valves. Connect the circuit as shown. So we are going to take, and we're going to run power. Let's see here, I'm going to start from the beginning. We're going to go from 24 volts to selector switch 1. From selector switch 1 to the circulator pump. The circulator pump back to the negative. Then we are going to go from the 24 volts to the flow transmitter auxiliary power. From the auxiliary power to the flow transmitter output AI1. Flow transmitter output AI1. Then we're going to go from the negative. We're going to go from the negative of the analog in, and we are going to go to the controller. The controller input plus, analog input plus. And then we're going to, from the negative, we're going to jump to, I'm going to use a short one here. No, we don't have this short. So negative to the negative.
And we're jumping back to the negative of the power supply. And then the controller analog output over to the IP converter, which is let's see here. Flow valve. Yeah, FV1. And then we're coming off the negative of that. And going to back to the negative here. The positive, over to the positive, and the negative to the negative. Alright, so that's wired as shown. So we're going to turn the main circuit breaker on. Once everything boots up, we're going to turn selector switch 1 on. When selector switch 1 comes on, we then will notice that we have, and I'm going to back this down just a little bit to give me a reference. So I have about 1.3 gallons on the rotary meter, and I have 1.23 on here. So you can see that they do jive up, that this meter is reading what is basically what is the same as what's going through the rotary meter. Alright, place the transmitter menu. So we're going to go through some of these settings in here and set this up. And I may run into just a little roadblock because it may ask for a password and I don't remember what that is. Alright, so now we're in the menu. We're going to go into Cal and we're going to go no, and then I was going to ask that. Up, down. So we want no, volume cal. Rate cal. Volume cal, we want, it's not applicable. Rate cal is not applicable. TF, we want 1.0, which we have. We want 3160, so we're all good there. So now we're going to go over to our next one. I don't remember how in the world to get this. Is it not like the I don't know why this thing doesn't. I always fight with this. Up, up, down. Okay. So once we go there, up, 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 down. press and hold. We're going to go into the cow. Okay, so all those are right. And it's a pain in the butt to get out, so I'm just gonna do it the easy way. So now we're going to go to inputs. Input is flow. Sensitivity is 100. Average is off. Gallons. Flow units. So our flow frequency. Flow, we're all good there. Milliamps, 24, 22, 1.5. Alright, so we're all good. Alright, so we have the flow meter. We're all wired up. Flow meter is programmed. Now we're going to program the Honeywell controller. So we're going to go into setup, we're going to go to algorithm, we want that to be PIDA, we're going to go into tuning, we want that to be, gain needs to be a 2.5, it's now 20, so we need to slow that down. .5 it is, and then a 0 for min, and reset is a 0.5. Alright, and input 1.5 volts, linear, high is a 1.5. If you guys hear some thunder or rain, we got a little storm moving through. .5. I hit the wrong button. But low is a 0. Bias is a 0. Because we're using the flow meter, not the transmitter. So control, input 1 only. Set point high. We want it to be 1.5, it is. Low is 0. Direct, enable. And then PCT, we need this to be 75. I'm hitting the wrong buttons. when it becomes a pain in the butt when you hit the wrong buttons. You gotta go back in. 5. Wait a while. PB is gain, min, options none and none, com is disabled, alarms, we're going to do none, and none. Display, we want 2 decimal places, 60 hertz frequency, language is English, and so we are now set up. So now we're going to make the set point of the lower controller 0.08. Control flow, turn the selector switch 1 to start the circulator pump. Place the controller in automatic mode. My set point changed, so I'm going to change this back to a 0.8 as it asked me to. And then if we scroll to the lower display, we see the output. Right now we're at a 1 gallon per minute. We want to be at a 0.8, so it's outputting the controller to close this flow control valve to slow the flow down. So this is reading the flow from the paddle wheel meter, and this is controlling the flow from the paddle wheel meter. So my set point is a 0.8. My output is fluctuating up and down to try to maintain that 0.8 gallons per minute flow. If I was to change my set point to I'm going to change my set point to a 1.0. As I do, the output will increase, which will open this air valve a little bit more to allow 1 gallon per minute to go through. Once it gets to 1 gallon a minute, it's going to open and close that valve just to maintain that 1 gallon a minute that's going through. Rotary meter is reading about 1 gallon a minute, so is the flow transmitter. We're outputting, everything's working like it should. No matter what we change this to, no matter what we adjust this set point, it's going to maintain it as long as the pump is capable of pushing that much liquid through. These are some calculations that you guys have already done previously. In the lessons that you did online. This next section is an ultrasonic level measurement and control. We do not have the ultrasonic transmitter for this trainer. If you did, it would mount up here. It would sit on top and it would shoot a beam back and forth, and it takes a measurement from the bottom of the transmitter to the level surface by how long it takes for that signal to bounce back and forth, and that will give you your level rather than using a level transmitter on the bottom for pressure. It gives you it shoots a beam to check the level in the tank. We don't have it, so we're going to skip over that portion. This is just setting it up and calibrating the ultrasonic level transmitter. going to go over a few things here. We're going to tie into this loop so we can see on a 4 to 20 meter the 4 to 20 milliamp signal that this controller is outputting to this flow valve to tell it whether to open or close more. So basically what I've done now is I've put this meter in a series loop with the output of this controller. So what you'll see is as this outputting is decreasing here, so is my milliamp signal here. I'm at an 8.4, 8.3, 8.2. So if you were wanting to read in a milliamp signal what was going on inside your circuit, all you have to do is just series this in. It's the milliamps, and we're going to go to DC milliamps, and your max that you should be getting on a 4 to 20 milliamp loop is 20 milliamps. So I set this on 20, and we're reading about an 8.4. If I was to change this set point, I'm going to take this set point down to a 0.4, it's a 0.41. So in order to slow this down, this valve has to close. And in order for this valve to close, the milliamp signal has to go up to this IP converter to allow this valve to open and close properly. So you can see my milliamp signal is increasing. It increased to a 12.8. And I was getting close, so as I'm getting close, it's tightening up, not adjusting as fast as it normally would to make sure it doesn't overshoot once it gets to its set point. So it's still closing a little bit because we're flowing a 0.51 and my set point is a 0.41. So it's just slowly closing, just trying to get it down to that 0.41. Now it's overshot a little bit, so you're going to see this milliamp signal decrease, trying to get there. I'll take this set point and I'm going to go all the way up to it. Looks like we got about so 1.5 is the highest I can go for the set points we put in the controller. In order to get to that 1.5, this valve needs to open, so we need to drop this milliamp signal, which it is. It's down to 10, a 9.5, a 9. So proportionally, everything is working like it should. It's opening that valve and closing that valve as needed based off of this flow meter giving this to Honeywell a analog input of what the flow is, and then this Honeywell is outputting an analog signal to the flow to the IP, which is converting it to pressure to open and close this valve to know where it needs to be. So we'll go ahead and shut that down. Once we shut that down, we should notice that because this device it's shut down, we still haven't got to where we need to be. We're at 3.97 milliamps, which is basically 4 milliamps, because it's saying, hey, my set point's a 1.5, I'm not meeting it, give me everything you got. So I've skimmed through and I've picked out the things that we really needed to hit on here in the process. The stuff that you had already done and the calculations that were in here that you went through in the computer lessons, I skipped those. And with skipping those, You feel free to go back in the book and go through them again if you want to refresh on them. But like I said, as I said, you've already done those, so they're not a huge deal. But that is basically the gist of the process. Like I said, it's kind of like a water plant. You have an aquifer where you're pulling the water from. You're putting it into a storage tank for use at a later time. Or you're sending it to the customer's house, whatever you need to be. You're going to use flow meters and valves to make sure you're within the regulations. Make sure you're feeding chemicals, you're giving the proper flow to a device, whatever you need. If you're in a factory, you know, they may have a cooling tower, and that cooling tower requires you to flow 100 gallons a minute through it. You'll use some kind of paddle wheel meter or some kind of ultrasonic meter to know that you're flowing at least that minimum, not more than the maximum to it. But this is the basics of process control and how it works.